On June 7, 1940, at Chrysler's headquarters in Highland Park, Michigan, a short telephone call set in motion one of the greatest industrial feats in modern warfare. The call lasted just 7 minutes, yet its consequences would fundamentally reshape how nations build the tools of war. On the line was William Knudsen, recently appointed by Franklin Roosevelt to coordinate American industrial mobilization, who posed a question that sounded almost ridiculous. Could Chrysler build tanks? Chrysler's chief executive, K.T. Keller, did not sugarcoat his reply. "I don't know," he admitted. He had never even seen a tank in person. And yet, within those few minutes, the first domino fell in what would become the most ambitious military manufacturing program the United States had ever attempted. At that moment, America's armored forces barely existed. The U.S. Army possessed a grand total of 66 medium tanks. Germany, by contrast, had unleashed more than 3,000 armored vehicles across Europe, crushing Poland in under a month and overwhelming France with terrifying speed. Britain, though more mechanized than the United States, could still field only 1,000 tanks a year. In terms of land power, the United States lagged behind smaller European nations. It ranked 19th globally and still relied heavily on horses. As Europe burned, the arithmetic was frighteningly simple. If the United States ever entered the war, its tank corps would evaporate in a single morning. After the call, Keller immediately summoned his top engineering minds, B.E. Hutchinson and Frank Zeter. Within an hour, the three were gathered in Keller's office, confronting a demand that seemed absurd on its face. The Army wanted 1,000 medium tanks. They wanted them in just a year and a half. And Chrysler, a company that had never built a tank, was expected to design a production method, construct a factory, develop an entirely new supply chain, and begin manufacturing, all from scratch. Hutchinson did some rapid math. Rock Island Arsenal, the military's main tank-building facility, produced 3 tanks per month. At that rate, building 1,000 tanks would take nearly 3 centuries. The Army wanted them in 18 months. Keller's answer set the tone for the entire operation. "We don't build tanks the Army's way. We build them our way."
The trio traveled to Rock Island Arsenal to see firsthand how tanks were made. What they found looked more like artisanal metalwork than modern manufacturing. Armor plates were positioned by hand, tracks were tensioned by experienced feel rather than measurement. Thousands of parts, manufactured with loose tolerances, were individually adjusted and fitted. No two tanks were quite the same. Keller watched quietly before stating the obvious. This isn't manufacturing, this is sculpture. The realization was immediate. The Army's methods could never deliver the quantities required. A new approach was necessary, one rooted in the precision, standardization, and scale of automobile production. Back in Detroit, Keller, Hutchinson, Zeter, and a small group of Chrysler's best engineering and production minds formed what they simply called the Tank Committee. They worked day and night in a commandeered conference room, tearing down the very concept of tank production and rebuilding it around automobile-style mass manufacturing. Their breakthrough came from asking a radical question. What if a tank were treated not as a bespoke weapon, but as a large, complicated car? Automobiles weighed far less and were less complex, but Chrysler was already producing thousands per day. The fundamental challenge wasn't the product, it was the method. The committee dissected the M2A1, the Army's current medium tank, and discovered that most of the production time came from compensating for poor part precision. If components were built to automotive tolerances, tight, consistent, predictable, then tank assembly could happen quickly and systematically. Skilled hand fitting could be replaced with standardized bolts, welds, and jigs. Hutchinson and Skelton proposed an idea the Ordnance Department initially found outrageous. build every tank component to automotive precision, then assemble the machine on a moving production line. By November 1940, Chrysler presented what would soon become known as the Chrysler method. Parts would be machined with automotive exactness. Assembly would be broken into discrete, repetitive steps. The hull would be welded rather than riveted. The entire tank would be built on a line that moved at a controlled pace, bringing the work to the worker. The Army's engineers doubted everything, from the durability of welded armor to the feasibility of a tank assembly line. But they could not dispute the central fact. No one else could deliver 1,000 tanks in the required time frame. Chrysler won the contract.
There was one critical condition. The factory must be designed by Albert Kahn, the visionary architect behind many of Detroit's most innovative industrial plants. Kahn's firm produced designs in record time. The result was the Detroit Arsenal Tank Plant, a massive reinforced concrete structure covering 1.25 million square feet. Its layout was engineered for efficient material flow. Steel entered at one end, completed tanks exited at the other. A sunken assembly line allowed workers to access the underside of tanks without lifts or pits, saving precious labor hours. The building could even withstand bombs. Construction began on September 9, 1940, on farmland north of Detroit. Work moved at a frantic pace. Incredibly, Chrysler began installing machinery and laying out their production line while the building was still incomplete. Winter arrived before the heating system did, forcing workers to assemble tanks in sub-zero conditions. To keep them warm, Chrysler brought a steam locomotive inside the building, using its boiler as a makeshift heater. The image of a locomotive puffing clouds of steam in the middle of a half-finished factory summed up the spirit of the entire project: improvisation fueled by urgency. Meanwhile, Chrysler engineers tackled countless technical challenges. The M2A1's transmission, originally hand-assembled, was redesigned into a modular unit that could be manufactured on an automated line and installed in hours instead of days. Suspension systems were standardized and built as complete units. Welding jigs ensured accuracy and allowed semi-skilled workers to assemble armor hulls quickly and safely. Ballistic tests proved welded hulls were stronger than riveted ones, finally convincing skeptical Army officials. Engines presented the biggest headache. The preferred Continental radio aircraft engine was in short supply. With no time to design a completely new tank engine, Chrysler engineer Harry Wilson suggested a radical solution: combine 5 automobile engines into one unit. The result was the A57 Multibank Engine, 30 cylinders arranged in a star pattern. Unconventional? Absolutely. But it used Chrysler's existing tooling, could be built immediately, and delivered enough power. The Army disliked its complexity, but approved it because it could be produced right away.
By early 1941, components were coming together, and workers, many new to heavy manufacturing, were being trained in specialized schools created by Chrysler. Thousands learned single tasks they would perform repeatedly on the moving line. Suppliers across the Midwest began producing precision parts under tight Chrysler supervision, forming a network of